So this is us. We're First Lamp Architects. We actually were also the builder. I think is kind of it's said in our description on the website. I acted as a certified passive house consultant on this, which means I was doing all the energy modeling in real time as we were building the project. Kevin and I designed the project together as architects, but I continued on as the passive house consultant. Kevin built the thing. So we have a lot of knowledge on both the design, the modeling and the FIA certification side of things, as well as the construction side. So it's all there. Feel free to use the chat to ask questions along the way. Just let everybody know this is being recorded. So if you don't want to share your voice or image, just leave that off. That's totally fine. The cool thing about it is after the fact, I think there's a paid version. If you do that, you can go back and watch they're going to edit the videos down from 4 hours to like 30 or 45 minutes. And when they do that, you can get back online and check out those, all of the projects. The second thing is, please mute yourself when you're not speaking. That way there's no background noise coming through. But again, please feel free to ask questions along the way. And if it gets crowded, maybe we'll try to focus on the chat. Like we mentioned yesterday, it doesn't sound like it's going to get too crowded. So probably not going to be an issue, but you're also always welcome to use the chat. Kevin and I will be monitoring that along the way. So if there are questions that pop up, we can either answer in chat or we'll answer it in person. Here's our sponsors. Definitely check these folks out there. The reason we're here. And here's a little quick video. We'll talk over the top of the video as it goes. So this is the project. It's in obviously Ballard. Something we started on, gosh, 2.5 years ago when we met the client, the client continued to work with us. We're going to go over that in a little bit, but they're actually a previous client of ours. Kevin and I built the project beforehand. They bought, and this is the second home that we worked on with them. Here's the courtyard. This is a big feature of the project, creating a courtyard space that would also allow for a lot of southern exposure. We'll go into that more, but you can see the solar shading and the windows. That's a big critical element of what makes a passive house work, is basically how you site the project and how the exposure works with, south facing windows with lots of solar gain. Just more shot to that's the garage you're seeing there, which was detached. We'll talk about that. Just more shots of the south facing windows and doors. We have big sliding doors out to the courtyard to kind of help blend the inside and outside. Kitchen. Just some shots of some interior, just fun shots of the powder. They had a little bit of fun with the powder room, getting little red vanity there. This is Stairs, major feature of the house. It's in the middle of the project, so we dialed it up, from a kind of fun standpoint, but also opened it up quite a bit. So the center, what you're seeing here is we've got a big window on the top, and then there's a giant skylight in the middle of the house. What that helped do is bring light in the middle of the structure and help brighten up the inside, as well as created in the skylight you're seeing now, which created a lot of solar gains, south solar gains. So in the winter, it's heating up the house. Again, south facing windows, you can see the light moving across there. We mentioned this before, but there's this is kind of a raised front element, so the house floats off the ground at the front. That was a program element from the client. We'll talk about the challenges we faced with doing some things that you wouldn't necessarily always do on a passive house, and how we kind of overcame those from a detail and a kind of a design approach to help it reach certification, which is, I think as Kevin was mentioning, we're going to talk a little bit more about this soon, but kind of what FIAS is one of the most rigorous green building certifications you can get, and that's for good reason. So here we go. So kind of going back, we had, talking about this, the house on the left was the one that was actually a duplex. The owners lived on the one on the right. You can see there, 3-story with a rooftop deck, 4-star built greenhouse. So it was energy efficient and very green in and of itself. But you know, we definitely dialed that up for the new house. You know, some of the primary goals were durability. As we mentioned, you know, passive house is definitely at the, you know, the high end of any kind of certified or built green or, you know, project that's durable. And we think about passive houses as lasting homes that last 100 years before any significant maintenance needs to be done, as opposed to your standard home, which is 20, 25 years. You're starting to kind of deal with kind of maintenance issues. And that's the top down, you know, wall systems, windows, doors, HVAC, and all throughout, but primarily having to do with the envelope or the exterior of the house. So you don't get mold and you don't have dry rot or water leaking issues or anything like that. So a lot of the durability and resilience of a passive house comes from really detailing the windows and the walls, or the exterior walls. We talked about a little bit greater feeling of privacy. So that's, again, that has the which is why you know, this is raised, and then there's steps up, and it's secure, and then the garage again is that kind of blocking to create privacy for the courtyard. Exterior patio over the roof deck. Again, there was a roof deck above, which was really cool, but you know, you have to go up 3 flights of stairs from or 2 flights in this case to get there from the kitchen. In this case, it just flows right out into the courtyard. Again, acoustic isolation, here talking about the byproduct of building a passive house is that they're incredibly quiet. As well, and we kind of mentioned the board, but also interior noise, and that was one of the reasons we used HRVs and ductless mini split systems. They're not only heat and cool and there's zoning involved, but they're incredibly quiet on the interior of the house. So yeah, I mean, this outperforms a 4 or 5-star built greenhouse or LEED Gold or anything by quite a bit. And again, if you wanted to build a net zero house or net positive house, the best place to start is with a passive house or passive house levels of insulation and window systems, because if you're starting with that much conservation, you don't have to do as many solar panels to reach kind of a net zero or net positive. Again, you know, of course, the growing family, when they bought the townhouse, that was just the 2 of them, and that is changing. Kind of going back to some of the elements of a passive house. What makes a passive house is super insulation and airtight construction. You can see here the yellow just kind of represents, you know, all the way around from the foundation to the walls to the roof. You're super insulating. So we're beating code by 2 to 3 times at least in every one of those categories. As well as airtight, which we'll talk a little bit more about. Balanced and continuous ventilation. Of course, there's which helps with indoor air quality, which is kind of what we're dealing with now in the Northwest, and the fires. And Roddy mentioned it earlier. We'll talk about it some more, of the fact that that's not even coming through. So inside of their house, there's not even awareness that there's this indoor air, exterior air quality. I think is at almost at 250 right now in Seattle, which is in the extremely unhealthy category. They don't even want us going outside. So inside the house would be incredibly good air. Passive house windows, doors, and shading. So, you know, not only the placement of the windows, which is critical to making a passive house work, and the shading, there's also the quality of the windows themselves, which have to do with the glazing itself and the frame, which allows for a very high level of insulation and U value and R value, which is well above kind of code. Because basically a window is sort of a hole in a house if you're thinking about it from an energy standpoint. It's very much a liability when it comes to how much energy loss or gain you're getting throughout the year. And so special attention needs to be paid to those. And of course, the whole idea is to lower carbon footprint. I mean, the number one critical thing facing us in climate change now is the fact that everyone's carbon footprint is so high. And that's what passive house focuses on the most. Lowering the amount of energy, it's directly related to your carbon footprint. The less energy you're using, the lower the carbon footprint. And if you can add renewables to that, you can get to a point to where your carbon footprint can be zero, which is sort of the ultimate goal, is to not put the pressure on, you know, municipalities and cities trying to come up with ways to be, you know, be carbon neutral. But if you can do it individually in each home, then ultimately, if we do enough of these, then it can help with the society and overall. Same thing, net zero or positive through renewables. So that's what that is. This is just a quick graph of what a passive house is. Hold on a second. Okay. There's passive house requirements. This we just wanted to show this because this kind of represents how kind of stringent and strict the testing requirements are to be a certified passive house. Most homes, or most certification, be it LEED or Built Green or what have you, is prescriptive. The thing about a passive house is it's tested. The first way it's tested in multiple ways, but the way that it's tested the most initially is the energy model, which we do in-house at First Lamp. So when we do the energy model as we're designing the homes, and even throughout construction, so we can kind of keep tailoring the way that we design the house, and trying to balance designing a really cool home that people want to live in with great lighting and good function and layout works, is trying to balance that with this energy efficiency. Well, we can do that in real time by doing this. And these are just kind of these ticks you can see are ticks that we're shooting for to meet passive house standard. But, you know, a code home, you know, the ticks would be out here. So even though we're close to, like, the blue is the performance of the home, this has to do with how much energy use you're using per year. We're beating passive house standards by quite a bit in some places and close in others. But again, that is not where code doesn't even deal with this. This is just to meet these stringent requirements so that the house meets all the expectations of a passive house: thermal comfort, indoor air quality, and whatnot. So this is kind of showing you what comes, and this keeps modifying throughout the design and construction process. But kind of overall design of the house and layout and like siding and orientation concepts, which is what this is showing. This is the orange is the house. The red arrows to below are kind of south. That's what we're thinking about most, and as far as making a passive house, is that southern solar gain. And then you've got the garage, of course. We've talked about that, creating the space for the courtyard, which is here in the middle. And again, kind of going back to it, we've got lots of windows on the south here for good solar gain, and even more on the top floor. And of course, again, if it's possible, this can be tough when you're working with sites inside of Seattle, because you don't always get to choose how your orientation works based on your neighbors and your lot orientation, or your lots running north and south. It can be hard to make the long side towards the south, but it was a unique situation, which we love, is being able to work with our clients and in the selection of the actual property itself, not only from a zoning standpoint, but in this case, we were definitely also thinking about the opportunities for it to be passive as we went through. So this diagram kind of shows more on the top floor. You can see these south-facing windows with the overhangs on each one that allowed for, again, control of the light. So conceptually, what you're looking for in a passive house with the south exposure is, in the winter time, the sun is very low, so it goes underneath these overhangs, and you can get a lot of solar gain that way. But in the summer, when the sun is really high and it's coming in like this, those solar shades are blocking the sun from coming in when it's hot. Therefore, you're taking the south light from adding heat to the house. And so that's kind of the big concept, at least from a passive siding standpoint. But the thing that we've tweaked a lot, in fact, this doesn't show, there's ended up being an overhang on this lower window. This was an early-ish rendering. I think these were ended up being a little deeper. by just a few inches, but like that's what we could do with the energy model. We could tweak things by just a few inches up or down, depending on, you know, what was the best balance between heat gain in the winter and blocking the heat in the summer, so we could balance that heating and cooling. This is just kind of, again, a shot. You can kind of see here where this overhang ended up being a little bit deeper than, you know, it shows in the model. And that was kind of one of those things that happened during construction. Before we ordered the steel, we're continuously checking back with our energy models. We tweak things, and you can see this also has an overhang over the lower window as well. You know, yeah, that's good form too. Oh yeah. You can kind of see here as well, we designed, even though it's sort of a modern house, we did end up shedding or putting a good slope on these southern facing roofs, so that we were able to, in the future, and I think in the near future, add the solar panels and able to make the house a net zero house, if they choose to put that many. But the idea is that if this is sloping towards the south, they'll get the best use out of those solar panels facing that direction. They'll be the most efficient. You can face them east and west, but again, they just lose efficiency that way. And so this is, and we set what's called future proofing for solar panels. So there's actually already a conduit running up to the roof. So it's very easy for them, and the structural design for the weight of the panels. So it should be very simple for them to retrofit or come in after the fact and add the solar panels later. More examples of just kind of south-facing glazing. You can kind of see in this shot, we've got this, you know, this is a very large window, and you can see the overhang out there. So, but this shot was taken more in the winter, and you kind of see how much light is coming in through those. And you see the light here on the sill. So getting a lot of good solar gain. You can see the light coming in here, that little from the sun, and that's all helping the heating and cooling system along. So if there's, you know, so the heaters don't have to work as much. And I think Roddy mentioned earlier that, you know, a lot of times of the year, they don't even have the air conditioner or heater on. It just kind of works the way it should. It's just one of the probably the most extreme situations, very cold or very hot, where there'd be, hopefully it's designed correctly, there'd be as much use for that. But yeah, reduce heat in the winter, reduce artificial lighting load. That's another thing. The more the natural light you come in, the less you have to have your lights on. Not a lot you can do about that in the Northwest when it gets, you know, the sun sets at, you know, 4:30 in December, but certainly balances out throughout the year, because we get a ton of light in the sun setting at 10 o'clock at night in the summer.
If I can jump in really quickly,
Yep.
talk about the Skylight. I know a lot of, and all of this comes from the quality of the energy model. And by that, I mean, like, not our project specific, but the quality of the software and how detailed it's able to be. So we added this Skylight, and everybody's probably thinking, yes, doesn't that also contribute to overheating in the summer? But because we're able to measure that too against the passive house standard, we had a lot of room with that metric. Like, we were meeting our cooling very easily. What we were having trouble with was our heating demand in the winter. So when we added the Skylight, obviously it moves both needles. There's that page, that slide that showed all four of the metrics. All of those move as you add and delete windows. So all we did by adding the Skylight is that helped us meet our winter warming demands, right? So that brought that down. And of course, it contributed to a little overheating during the summer, but we were beating that metric by enough that we could take that hit to that metric, still pass, the home still works the way that FIAS and the Passive House organization wants it to work. But we were able to, because of that Skylight, the heating system, you know, as we installed it, could carry the heating load during the winter time from all of the gain from that Skylight.
Yeah, and quick game update. Seahawks are beating the Falcons 14-9 so far. So we appreciate you guys being here. But just in case there's a couple of football fans. All right. This is just more examples of just kind of exterior shots of those kind of strategies, and you can kind of see how deep, even from the rendering, I think we expanded it by 3 to 4 inches by the time it worked out with the way it all worked. But again, this might be a good place. There's another place, but there's definitely a balance that we were trying to play when we designed this as architects that want to just kind of create the best possible space with the lot and configuration that we had against the energy efficiency of that, and in order to be certified, be a certified passive house project. So some of the elements are almost acted against it, but because again we were doing everything in real time, we could balance those things with the model, and that was the advantage of the model. It's like, well, if we did, for example, we've got this move where we've got these tall, skinny windows. Well, they create this amazing light that moves through the hallway, and it's just this kind of this great feeling space. But if you were going to do a passive house, you'd want to avoid doing that. There's a lot of frame to glazing ratio, so that hurts you, as well as you can see here in this side here, like the shading in the summer only covers this much. Well, this is all, these bottoms will always be exposed. So that's what we balance. We balance that against making some other moves on the north and east and west, and reducing the size of other windows, or increasing, like adding the skylight or those things as we move through to kind of help balance. So we're still meeting all of the goals and expectations of doing a passive house. So one of the most critical things and elements and methodologies you can do in order to make a passive house or any green home energy efficient is air sealing. You have to build as tight a house as you can build. So that has to be balanced with good indoor air quality and balanced ventilation. But first things first, you've got to make it airtight. So you can kind of see here in these images some of the links that we went to, and this is all foundation. So this is literally just with these really cool special tapes, taping the underlayment that goes under the slab, taping it to the foundation. And because ultimately what you want in a passive house is to be no gaps all the way around, from the bottom, the floor structure, even a slab on grade leaks air to the exterior walls, to the roof, and you kind of want to draw a line away around your whole house with an uninterrupted basically line of air sealing. So you can see here, like we taped where the pipes, the future plumbing pipes, penetrate that air sealing barrier that's going to be underneath the concrete. And then here's our guys coming in here and just methodically taping everything to the foundation wall, because that ultimately ends up tying to the walls. And then the walls, you can see kind of on the right, we use this product that's it's called Prosico, but it's a liquid applied membrane. It's durable, lasts as long as the house does. But all the pink you can kind of see here, spanning and filling each gap between the edge of the plywood, corners. These are the window buckouts. The reason those are so deep, by the way, is so insulation can butt up to it, the exterior insulation, which we'll talk about next. You can kind of see even on all the ends and corners, and we just want to, every penetration for both, those are bolt penetrations. And then even the special tape, this really cool special tape that we kind of tape around that tapes and connects to the membranes that are below. So you get this uninterrupted kind of air seal around the house. And then of course we've posted these signs all the way around to tell the plumbers and electricians, don't just start knocking holes in our really cool passive house. Yeah, so, and that air tightness, again, we kind of go back to what makes passive house special is it's tested along the way. And from the model at first, and then it gets tested here with what's called a blower door test. And we're really shooting for a really low number, which is to say we depressurize the house to 50 pascals, which is what this is talking about, which is a certain pressure that they've kind of predetermined as a good number to use. And then we kind of measure how much air we're losing. And so what this shows is what's a good number to hit. Well, the Washington State Energy Code is 5. So that's to say, and we have a pretty advanced energy code that shows that, even in Washington State, we're advanced, we're at 5 an hour. Built green is kind of 2 to 3.5. FIAS wanted us to be at 1 to be a passive house standard. We had to be at least meet a 1, but our project was about just over 0.4. So just as a reference to what standard you're moving towards, you want that as low as possible, because most of the energy loss is through just air loss through a house. So if as air moves over and through insulation, that insulation value, the R value that it's sold as, drops significantly because it's carrying all the heat and moisture with it as the air moves through. Also, that's creating potential for dry rot, mold issues, and all those sorts of things. So that's kind of why that's critical.
And I want to hop in really quickly just to make a point that is sometimes people kind of gloss over or don't really grasp. We're pressurizing the building or depressurizing it to a difference of 50 pascals. That happens all the time when the wind blows outside, right? You have a negative pressure on the lee side of the building that as the wind blows, it does pull air outside of your home. You have a positive pressure on the other side where air is coming in through the building. The test standard, and therefore, what the way buildings are tested, is 5 air changes an hour. That means under normal circumstances, just when the wind is blowing outside, you can expect all of the air in your home to change itself out 5 times. So you can imagine, like, just that all by itself, forget about the cold air on the outside of the building, just by doing that, by changing the air out that often, all of the things that your heating and cooling system have to do. And so just cutting that in half to the built green standard of 2.5 or 3.5 it just makes huge gains. The only reason I'm reiterating this is most people, myself included, before Taylor and I began educating ourselves on these things, have no idea that much air unintentionally goes in and out of your home. I mean, we're not talking about the HVAC. We're not talking about any of the stuff that you're planning on, like your dryer or any of the fans in your bathrooms. This is just unintentional air leakage. They did, the closest thing that I could find, there was a survey done of about 400 homes in Wisconsin one time. In 1999, the median air leakage of those 400 homes in 99 was 6.5 air changes an hour. So if your home is older than that, there's even more air going in and out of your home all the time that you'd rather not have. So that's it.
Yep. Critical. So the next part after air sealing is, basically a super insulated envelope. And what we're showing here is kind of the different parts. We got on the left, you got the foundation, in the middle of the walls, and then the right, the roof. And so one of the strategies we used for below grade were these super thick, this is EPS foam. And you can kind of see how thick they are to meet an R60 below the slab. So that's between the slab and the grade. We've got an R60, and that's as an equivalent, as we're talking about a code home. A code home requires 0, unless you're doing radiant heat, and then you have to have R10. At least sometimes you have R10. Well, code in Seattle, you have to have R10 around the perimeter for a couple of feet, but in the middle you have none. In this case, you see how much went over the top of that. We had, a foot of foam underneath our concrete slab. And of course, over that, you saw earlier the air sealing, all that air sealing you saw with the membrane and all that was over the top of this. So we put that on top. That's where our air tightness came in, is above this. On the walls, of course, we used 8-inch thick, we used 2x8s to frame the walls. So we had 8 inches of blown in fiberglass insulation, which in and of itself would be pretty good. But then on the outside, we added this 5 inches of wood, what's called wood fiberboard. And this is a pretty unique thing at the time. Very few people, if any, had been using this product as exterior insulation in the Northwest. It's becoming a little bit more common. You guys may have seen, if you go to Brian Cowan, there's a friend of ours and another builder that used it on his house as well recently to great success. But what's great about this stuff is it's got incredibly low embodied energy and low global warming potential, which is to say the product itself is incredibly, it took a lot, it took very little energy to make, and then it's also being used, all the product in it is basically chips of wood from post-consumer factories making, they just basically took the sawdust and compressed it from wood mills and compressed it into these fiberboards. So it took very little energy and to make it. So but it has a very high R value, and anytime you put this much insulation on the exterior of the framing, what you don't get is, well, basically you're creating a block of energy between the exterior and the interior. It's called thermal bridging, is what it's kind of commonly referred to, which is to say you don't have a solid piece of wood, times every 16 to 24 inches touching the inside of the outside, because at every single wood stud throughout a house, if you don't have exterior insulation, is a heat sink for the ability for heat and cool to transfer into the inside of the house. So if you have exterior insulation, you're blocking that thermal bridging from being able to happen. And then if you're doing it with something that doesn't take a lot of energy to make, ultimately your total energy use for that product is saving immediately. Some foams, they say, if you use like EPS or XPS on the exterior house, can take as many as 20 plus years to meet the energy savings of the house is what it took to actually make that product. So what we try to do where it's possible, it's impossible underneath the slab because that has to touch water basically and degrade. But on the exterior, we try to be as foam free as we can be. And this house definitely achieved that. So, and then you can kind of see in order, I mentioned this earlier, but you can kind of see how far these, what's called a window buck or a framing that sticks out past the window, that again is just to receive the thickness of this slab. So when it's all done and we do the siding, we can start the siding from that point on. The roof was R96, where code is on a roof like this is R39. So we're well more than double code insulation on the roof. The roof is very much exposed and gets solar gain all throughout the day. So it's certainly something that needs that much R value in order to kind of achieve a passive house. And then the next element is, of course, going back to what your global warming footprint or your carbon footprint is. A big piece of that is like just overall energy use. So if you could save it with insulation, we're saving with indoor air quality, and we're using efficient mechanical systems, which we'll talk about next. Ultimately, you're down to how much energy are you using inside the house. So this house, like most green homes, use all LED lighting, Energy Star appliances, in order to reduce the overall energy use in a house. Also, can you mention here, it's like, the things on timers and photocells. And if you do daylighting right, then hopefully you don't have to use the lighting as much, which the lights and artificial light as much as you need to. So, yeah. So the next piece, which gets into the inefficient ventilation. Again, once you build a house that's a super airtight, if you don't, you're eliminating the ability for any natural air to come in. It's critical that you bring that air, that indoor or the outside fresh air into the home. And the best way to do that, in our opinion, and certainly something that works well with the passive house, is with a heat recovery ventilator, HRV for short. So what an HRV does is it draws in air through filters from the exterior of the home, and then distributes that throughout all the habitable rooms and spaces in the house. So, and all the while being filtered along the way. And at this case earlier, I don't know who was sticking around or heard this earlier, but it's a MERV or MERV is kind of the rating of the filter systems. And this particular filter has a MERV 13, which is hospital grade air filters. And that basically, like right now in Seattle, we mentioned this, I'll double check where we are right now. Right now, Seattle is at 260, which is a very 260, which is a very unhealthy, considered very unhealthy on the exterior because of all the fire. So anything above anything above 200 is very unhealthy. Unhealthy starts at 150. Unhealthy for sensitive is 100, and moderate's 50, and a good air quality would be between 0 and 50. We have the worst air quality in the world right now because of the fires, which we can't control here in Seattle, but because the wind's blowing those through. Well, inside the house here, where in this house, they don't even notice it. There's no noticeable. They're not measuring the indoor air quality. But right now I've got a Dyson indoor air filter running, and it took about half a day for it to get to very poor quality air inside my house down to 0. So it's got about the same filter as this. So presumably the indoor air quality is very good inside the house, and they certainly aren't noticing anything. So this is going to become more and more critical, I think, as we in the future. I would definitely, we recommend very heavily to not just do the standard indoor air quality balancing of any house, but to maybe consider an HRV. But also what's critical to that is centrally locating, which is what you're seeing here. If it's in the middle of the space, one, it's cost effective because you're not running, having to run very long duct lengths, which you could lose efficiency in that. But also you're not running any of those ducts in exterior air or exterior envelope, which was to say like through an attic space or through an exterior basement or even in the exterior walls. None of the ducts are run through those, so therefore their interaction from a heat gain and heat loss standpoint is within the thermal envelope of the house. Therefore you're not losing, you're not cooling. Like if it was on the exterior in an attic, you'd be cooling down the air as it distributed from the mechanical room to another space. And for fresh air, the whole point of a heat recovery ventilator, or one of the points of it, of course, is the fact that it does heat recovery, which is to say when it pulls in cold in the winter, cold air from the outside, it has a very, actually, I would say sophisticated, but sort of simple in a way, just these chambers. So the air doesn't mix with the interior air, but they share energy through basically just very thin aluminum plates. And what happens is the cold air from the outside gets heated up by the stale air being ejected to the exterior, and therefore not putting as much energy load on your existing HVAC system. So those also don't have to work as hard. So that's kind of the benefit of doing an HRV. And it works very well depending on your humidity levels. You can also use an ERV, but depending where in the world, in the West, around Seattle, HRVs are the way to go. ERVs are great in drier climates. And of course, like everything with Passive House, everything is tested to to a very high standard. I mean, Kevin, I don't know if you want to talk
Sure.
about that a little bit.
Yeah. So part of, part of what certification, meaning we're designing a passive house, there's an organization that's kind of overseeing it and verifying that, yes, you did indeed build it to this standard. One of the benefits that you get from that is this required testing. So back on that previous slide, you kind of saw the planning drawing, right? The document there that said, okay, this is going to be the layout for the heating system. We're going to supply this much air in this room. We're going to take this much air out of this room. And you kind of go to every space, top to bottom. Well, that's great. That's a design exercise and a planning exercise. You also, at the end, once the home is built, you go back and test. And FIAS, the organizing body of Passive House, states that your heating and cooling airflows have to be within 20% of design. And your ventilation airflows need to be within 10% of your design metric. And this exercise that you're seeing is not performed on houses that aren't certified, whether through FIAS or Built Green or LEED or any of the other organizing bodies that you go through for certification. This is a major advantage of this. And I'll have to say, I built this home when it came time to schedule this, I thought, we're going to be in there for 2 hours. They're going to come in, they're going to do the things that you're seeing doing here, and it's all dialed in. This is really good technology. We're going to check this box and move on. We did two visits at 5 hours each to dial the system in. And we did meet it, and that's nothing against the installers. That's a testament to how careful you need to be when moving from planning to execution, making sure that things are installed the way, you know, these the lines of the ducts, they go where you plan them to. And all of that efficiency that you baked in at the beginning of the process when you were planning, it does come out on the other side, and it does make a difference. So in that first slide on the left, he's testing airflows. That's the way that you test. You hook a little device up to this boot that covers up one of the supply registers, and it just measures how much air is coming out of that heating and cooling register. The two slides on the right, or the center slide and the one on the right, that's our rater, Tom Balderston, dialing in the flows of the ventilation system. The good thing about these Zenders, and I did put a link in the chat for the type of HRV this is. The good thing about these is there's plenty of basically knobs that you can turn to dial them in, that even though this is very low, this is not high tech. We're talking about, like Taylor mentioned, this is a fan with a heat sink and a heat exchanger in it and a filter. It's really low tech. That said, there's lots of tubes coming out of this thing that need to have dampers or need to be controlled so that all of your air isn't coming out of the hole that's closest to the machine itself. Again, this exercise usually isn't done on a home unless it's certified by somebody, whether it's FIAS or Built Green or whatever it is. So this is very important. And then in that last picture, he's actually hooked up a voltage meter to see how much power the HRV is drawing. A lot of people say, wait a minute, we're building this really energy efficient home. We're air sealing it, and we're making it as airtight as we possibly can, and then you're going to have a fan run 24 hours a day, 365 days a year? The answer is yes, because we're talking about like a 40-watt fan. This appliance does not draw a lot of energy. It saves way more energy by doing what Taylor described, which is moving heat from one side to the other. This particular unit is 92% efficient, meaning that in the wintertime, as cold air is coming in, hot air is going out, this unit is able to move 90% of the heat from one to the other, which is pretty remarkable when you think about it. Because you want fresh air in your house. You don't want 40-degree air coming into your house 24 hours a day all the time. That your heating system then has to reheat. So you get the best of both worlds. You get fresh air that is heated by the air that's leaving your home. And yes, that is a fan that runs all the time. Very quietly, slow and steady wins the race as far as these go. So that's a little bit behind kind of the images and everything that you see here.
Awesome. We do a quick floor plan review. So streets out here, main entry up the stairs, and then you come in the front door between the garage and the opposite the garage. Little mudroom here, powder study is part of that, and then actually our water heater is under here. And then this is, again, this whole section is raised up off the ground. So the challenge for that was to kind of detail the floor of this, which is basically becomes another exterior envelope or facade. We had to insulate the bottom of this in order to, meet our energy demands. And And then, you kind of come down, and then the space gets tall again, and then we've got, kind of this living dining kitchen that's open up to the courtyard. So we got these nice big sliding doors that allow for good, especially this south one, good solar heat gain. Facing the kind of this courtyard, which is sort of kind of the main feature of the house. The garage also, as we mentioned, is helping to screen and create some privacy and security from the interior courtyard from the main street. And then this kind of connects to the backyard. And then up above, you come up the stairs. We have that centrally, again, that skylight is kind of about right here, flooding the middle of the house, the darkest part with light. And then you have the 3 bedrooms here, and kind of the primary down at the end with lots of good south-facing light, but above the garage now. And of course, going back, that laundry mechanical is centrally located there. And that's kind of the floor plan. Simple, efficient. I mean, definitely efficient envelopes, which you're going for. The simpler the envelope, the less cost, because cost is always a big question mark. So there's always a balance between the program goals and the envelope, but you can kind of see how simple we made this. It's just purely a, this L shape. Not a lot, the only cantilevers or overhangs are above the ground floor, but everything else is stacked above the ground floor. So again, the less exterior envelopes and exterior walls as possible, balanced against creating beautiful architecture, which of course is what we're trying to do. So, we found other ways, a good strategy for passive house, of course, is, you kind of make the envelope simple, and then all the fun, interesting architectural features you sort of attaches to it. Going back to that thermal bridging idea, where we want to kind of separate the two. That was one of the nice things about the garage, is because it wasn't a part of the passive house envelope. So we got to have quite a bit of fun with what it looked like, the materials, and we weren't as nervous about, creating angles and whatnot, and some complexity there, because it got to be kind of its own thing to help define it from a spatial standpoint, but also help define it from a kind of architectural and kind of architectural design standpoints. So this is kind of the back. Oh, go ahead.
Can you hop back to that other slide? There's one other benefit I'd like to mention.
Yeah.
Not only whenever you really pay attention to the way the envelope in a house performs like this, and you just basically super insulate it, all of your mechanical systems, everything, even though we're talking a lot about them, the amount of room they take up in the house shrinks dramatically. So Taylor mentioned pretty quickly, like that space that's labeled laundry mechanical. So there's a laundry sink in there, their washer and dryer is in there, their heating and cooling, and their ventilation, all is in that space. So on a standard home, even on a code minimum home, a house that you would build today in Washington State, most of the time that space is how much you would need for a forced air furnace and all of the other equipment that's going to go in there. But we were able to, because the actual physical space that these things take up is so much less, because there's so much less demand on them. Right, so we're talking about not only really energy efficient appliances, but very nimble. It's important that they're in the middle of the building, like we mentioned, but you're not having to put a lot of space, like an entirely separate room that's just devoted to a furnace, like you did in a standard home.
Excellent point. So yeah, we kind of go back here, and this is the kind of the backyard. This is, by the way, we didn't talk about this before, but this is a Seattle requirement for drainage. That's a bioretention swale. So when you collect the water from the roofs, they get diverted into these, so they don't overwhelm the existing infrastructure of the city. That's going to be a pretty standard requirement for any house you build in Seattle, but it's worth mentioning. And yeah, so this kind of small windows, not a lot on it. This is the east side. But the sliver window was basically the backsplash of the kitchen, which you'll see from the inside. And over here on the right image, you can see, kind of the garage, how we taper the roof to allow west sunlight as much as we can possibly get in the courtyard. Yeah, how we can kind of fun with from a design standpoint with the exterior of the garage and how the kind of the courtyard interacts with that. So there's a lot of wood and rusted steel panels on the roof and whatnot, which is kind of cool. Oh, and I'll say one more thing. This is a pretty good example of kind of how windows are installed in a passive house because there's so much exterior insulation. And I mentioned the buck out before, like the thickness of the insulation of the exterior of the house is that thick. So what do you do with this? So in this case, we kind of played it up. We got the same species wood as the windows were made from and created this kind of wood wrap in the dark material to kind of highlight that feature, which is most homes, standard code built homes, the windows are right on the face of the exterior insulation. So you don't get these kind of reveals and shading. And so kind of a neat thing for, us as architects to kind of have a little bit of fun with. Kind of saw some of this, we kind of talking about in this angle here, this is that kind of space, the gap between the garage and the house, the entry is behind this, and we kind of built this screen that integrated into the siding in order to create that security so that there was no access from there through, along with, kind of creating some kind of relief to the street and light to kind of come through as the sun sets. Another shot of the courtyard. This is kind of highlighting it from the other direction, highlighting kind of the connection between the dining and the living to the courtyard. So it all kind of felt like, one space. These sliders slide in one direction, that one slides this way, that one slides this way. So this sort of center part becomes entirely open on nice summer days or evenings. So that kind of really integrates and blurs the line between the courtyard and the interior of the house. More shots of the garage. Kind of detail, again, south light. Going back to the inside, again, efficient lighting, kind of cool modern kitchen. We had a lot of fun with that. Yeah, powder room. Again, this kind of shows this powder room shot. So this is a window on the north. And so on the north side, we really get to be careful about how much, how many windows and how big they are on that side. Because that's basically because we're a heating dominated climate. So, which is to say in the Northwest, most of the months of the year we're heating. We're not using air conditioning. If you're in the South, you're in Texas or Florida, or so this all flips. You can change the amount of windows you put on the South versus the North. But here, basically every window you put on the North is a heat loss, and that much more, potential energy you're putting into needing the heating and cooling system to take over. But at the same time, we like natural light, and and also it's nice to have natural light in spaces. So we're just very strategic about where we put those. Again, in this view as well, I mean, this is a north-facing window, but we felt like it was nice to have a light break between the kitchen and the dining room. So this kind of create some natural light over on that side. This is east facing out of the primary. Just kind of a good detail shot of how we did the overhangs. In this case, we haven't talked much about this, but all the overhangs on this house were steel, just basically plate steel, that created this really thin kind of sort of sexy architectural, like clean line that moves around the house, but as well as adding kind of providing obviously the shading that we needed for blocking the summer sun. Yeah, and here's the stair, again, kind of going back to, the multifunctional element of this design is, this railing that's also the support, it's the structural support, it's also the balustrade for safety. It's very open. So the skylight, which is up, up here, is kind of washing down, natural light. So, the Northwest, it gets pretty dark in the winter here. So we, as much natural light as we can get balanced against that heat loss and solar gain. But this was a kind of a fun design element. We got to play this up, and then by floating this, create this kind of seating element below the stairs that kind of gets some of that natural light flowing through. Just another shot of the skylight. This is, looking up, get that good solar gain. And then it's just kind of light washing down. Open treads as well. or risers, I should say. The hallway, this kind of.
Sorry, Taylor.
Yeah,
I was distracted. Sorry.
No, that's all right.
Did you address me?
No,
Oh,
no.
sorry.
Unless you want to add something, go for it.
I mean, there's plenty of stuff. I think you guys covered it. I'll let you finish, and then when we get to the questions.
Okay.
I'll
Yeah,
jump
great.
in.
Yeah, I'll jump in really quickly. In round one, Rade, we got a question about kind of noise from the mechanical room. And Rade during round one spoke really well about it and kind of described it pretty well from his own experience. So we will circle back to that as soon as we get through the slides. That'll be kind of the top of where we begin.
Yeah, we're getting pretty close to the end of our slides, and just for everyone that's new, yeah, Roddy is the owner. Kevin and I were the architect, designer, and builder, but it's great to hear it from the user perspective. And so we're about to wrap up. So if anybody has any questions for Roddy, feel free to throw it in the chat, or you're gonna have this in a second. Feel free you can even unmute and ask a question, and we can just kind of do it that way as well. So. Because it is, I think, exceptional to hear about the sound, the thermal comfort, all these things that we kind of promise in a passive house until you kind of hear from someone using it. It's like, it seems like so many promises, but it really, we were even excited at how well it worked out. But yeah, so south facing window in the master here, you can see our primary, I should say, bedroom, and then, but high for privacy. But these, it's one of the lessons learned was the difference between a window on the south that's skinny and short with an overhang performs much, much better than these tall ones do. That doesn't mean you don't do it. That just means that because these perform other functions like lots of quality of light, the way that the light moved across the floor and is kind of this repetitive nature in the way it changed throughout the day is pretty exciting from an architectural standpoint. And lighting standpoint, and also makes a deep hallway feel more open as you move through it. But we had to balance that with other moves to meet our energy expectations. But yeah, this is again the kind of fun with by the way, Mandy Calloway did all the interior design for us, and this was largely her doing, and then. This is a great slide. This kind of highlights kind of what the north side. So this was the north side of the house, right? And so you can kind of see we were very selective about where, we could put windows. There's a whole lot less of them. Again, if we were designing this house in Arizona, there'd be a lot more glass on this side, because we would want to be, if half or more of the year you were worried about cooling, you would want to be able to use the north side to release some of the interior cooling. But going back to the energy model in the Northwest, we're a heating dominated climate. So we want to, focus on that as well as on the east and west side. So Kevin, you want to talk a little bit about?
Yeah, so as we were designing this, we would kind of bounce back and forth between our architecture models, where we see the building itself and push and pull on the geometry. And then we would plug that information into the energy models. And what we kept finding is, like Taylor mentioned, the model was telling us we were overheating in the summertime. So, these windows that are facing west, they started out, almost floor to ceiling. And we kept shrinking them, so that the house itself wouldn't overheat in the summertime. We were lucky in that the owners didn't desire a lot of windows looking out onto the street. So we had some of those. In fact, they kind of preferred the scenario that we have. They preferred privacy and not a lot of view lines coming in from the street. So it's just a good case of like when you have sort of two design objectives that kind of overlap, it makes the process of designing a passive house that much easier, because, and the same thing with the windows on the north, you can see they're kind of sparse because we kept losing heat in the model with our north facing windows. So we kept having to pare those down too. But that didn't really impact the design you know, we weren't losing something that was very special architecturally or, you know, to the owners from their perspective of what it's going to be like to be inside their house. So little bit of luck, little bit of, you know, really leaning on kind of lot selection, you know, that planning and finding a lot that's going to offer you kind of that longer axis heading east-west, so you get more south facade, and really spending a lot of time in the early part of design. We call it pre-design or programming, right? We're not even really drawing yet, but we're trying to understand as much as we can about what the goals of the clients are, and you know, how we're going to be able to get the house that we want to perform the way it does from an energy standpoint. So kind of balancing all of those things. The more work that you can do on the front end, it sort of makes all of your other decisions and all of your sort of prioritizing things that, you know, the decisions you're going to have to make through the design that much easier. So.
Yeah. I think this is kind of our last image, just sort of that's kind of it. So I think, yeah, if anybody has any questions, there's been some Kevin's been answering in the chat as we go, but yeah, now's a good chance for Roddy to, if you want to kind of jump in and have an overall thoughts about the house, go for it.
Sure. Thanks, Taylor. Hi, everyone. I'm Roddy. As Kevin and Taylor mentioned, I worked with them to build this house. Let's see, a couple of things that probably worthwhile mentioning. Kevin talked about, I mean, I think Kevin and Taylor touched on many things, but just from our perspective, I think it's important. Like, I guess I'll phrase this in the context of, if I had to do this again, like advice that I would give myself. So hopefully some of this will be useful. The first thing is, I think Kevin touched on this, and I think Kevin and Taylor did a great job of sort of forcing us to organize our thoughts and to really list down what are the things that are very important to us, because at the end of the day, building a house, like many other large projects, is a collection of trade-offs. So you gotta approach it from a disciplined perspective about what is most important and what are you willing to trade off for other things. From that side, having extremely quiet home and extremely comfortable home when it came to like temperature were two of the most important things, in addition to high ceilings. And you know, Kevin and Taylor didn't spend a whole lot of time talking about the high ceilings aspect, but the house definitely has that aspect of you know, design criteria that we were really after. When it comes to a couple of the things that Kevin and Taylor talked about as far as like ventilation system, the HRV system in the house is extremely quiet. And I think in large part because the system is just designed to be quiet is the first point. And then the second thing is the house actually has sound insulation between every room, which wasn't particularly cost prohibitive to do when you're building the house. So so that is one way that we basically accomplish such that, like, you know, the house is super quiet. It's actually so quiet that one of the sort of things that we needed to follow up after the house was done and we lived in it for 6-7 months was I complained to Kevin that the squeaking of the doorknobs when you open them is too loud. So that kind of illustrates how quiet everything else is when that becomes the most annoying sound that you can hear in the house. Let's see, that was on the quietness of the HRV system. And then I think Taylor mentioned this, but I hadn't actually, until this presentation, I didn't know that the HRV system has an MERV 13 filter on it, in addition to 2 additional filters. One is the MERV, I think one is MERV 7 and one is MERV 8. But when I walk outside the house, I can smell the air because of the smog and the smoke that's over Seattle at this moment. And when I go inside my house, I can't smell it. I don't have a device to measure the air quality inside my house. But it's pretty clear that, like, as it relates to the smell, like, the system definitely does filter out. And the MERV 13 filters are basically designed to they're electrostatic filters that, attract particles that are 1 micron or larger, which is a pretty tiny thing. Then I guess I'll give you guys two last pieces of advice that I'd give myself if I were to start again. One is, if you're going to embark on a project like this, you should definitely work with people that you trust. So there's, like I solicited a bunch of feedback from various people when my wife and I were trying to sort of decide whether we should do this. And there's many times when people told us, oh, the markup of the builders is such, and then this is how the industry works. And ultimately what it boils down to is, if you have trust in the people that you entrust to build such a large project and to work with, then everything else is orders of magnitude easier. And I think Kevin and Taylor in that regard, like, they've always been super trustworthy people that they're always open book. Like, we always knew everything in terms of finances and then how the project was progressing. So that is one aspect that I would say is probably most important, as you're evaluating who should you work with. And then the last thing that I'll say is, passive houses are very atypical. As a matter of fact, I had a question for Kevin and Taylor. I don't know if you guys know how many passive houses are in the Seattle area that have been built or are being built. Because they're unique and unusual, they require things like, everything else that was talked about in the previous 30 minutes. And what that means is, you typically are not going to be able to go find a large home builder that is willing to, in addition to meet your own requirements about, like, hey, I would like, I would like the high ceilings, I would like this, and I would like that, right? Like, and on top of that, I would like the house to be passive. So, like, can you take all these constraints and design a house for me? Right? Like, most builders that build a lot, or most architects who design a lot of houses, do not just have the willingness to spend the time to do that. So that is all culminates with the point of, time is the most important variable that you have to have in terms of flexibility when you embark on a project like this. So work with people that you trust, and then definitely have right expectations from your own setting for your own self, for how long something will take, and then how long something will extend, even though, like, you built the plan. I mean, I gave this example in the previous, in the first version of the talk. Like, this was a real case from our project, right? Like, we had a plumber. The plumber, like all other plumbers in Seattle, has a lot more work than he can get to. And Kevin was like, hey, like, you need to show up this week. So, like, we got to get this thing done. And the plumber was like, well, I didn't agree to that. And by the way, I didn't agree to these two other things that, like, you're basically pressing me on. And at that point, Kevin just decided that, like, the most prudent thing was to basically go find another plumber. But that introduced the 2.5 week, I mean, I don't remember if it was 2.5, but it definitely introduced delay. These are the kinds of things that, like, you just have to be mentally prepared that it cannot, it cannot frustrate you, because that's the reality of working in the building industry, right? And Seattle as a market right now. That's the other important thing. Did I miss anything, or anything else that Kevin, Taylor, that I covered that would be worthwhile mentioning for this audience as well? I mean, this round of the audience.
I don't think so. I think the big thing is just, the big goals were thermal comfort. That was pretty well achieved. I think Roddy mentioned earlier that, a couple of small tweaks on the east facing. I think these going back to this, by just putting some internal blinds, because it's hard to control the heat gain, as Kevin was kind of going over. So, you just put some blinds up there. And then it's been meeting our hope, or exceeding potentially.
Yeah, I mean, the house,
comfort.
Yeah, I think, Taylor, I should have said the house is phenomenal to live in, right? Like, I mean, like, this was, for us, it was, I think, more than 3.5 year project. We didn't build the house for that long, right? Like, but when we started looking for place for lots and so on and so forth. And, like, in hindsight, like, the house is just amazing to live in. Like, every time when my wife and I comment, or typically when we go somewhere on vacation, when we come back home, it's like, wow, this is, like, super awesome to live here. And I'll give one additional thing. Like, one time we went up to Canada. It was in the middle of the winter and we were gone for 10 days. we turned off the heating system, but we did not turn off the HRV system, the air ventilation system. So keep in mind that while we were gone, the house was not being heated. This was like one of the coldest weeks this past winter. We left the house, inside the house was 72 degrees Fahrenheit. When we came back, the house was 69 degrees Fahrenheit. And there was like 10 days of no heating, no humans inside the house to like warm up the space. And there was circulation of the air from the inside to the outside. So Kevin and Taylor talked about the fact that the HRV system is 92% efficient. Basically, the house lost, like 3 degrees Fahrenheit of heat in the 10 days that we were gone. And probably the house lost more, but because certain portion of the heating of the house comes from the sun, because the blinds were up, right? Like during the day, the house would heat up and then it would. But anyway, that kind of speaks to how comfortable the house is to live in relative to heat and cooling and air.
Can you, Radek, can you speak a little bit? I know you've been shopping for solar, and you and I talked 6 or 8 weeks ago about the size of the system and how much you were factoring in for electronic vehicles and all of that. But can you just kind of give a summary of that, where you are?
Sure. Yeah. So I've been I have quotes from a couple of places for solar. I deliberately chose not to put solar when we were building the house because I wanted to live in the house. And more importantly, we have one electric car, which we drive most. So we put most miles on that vehicle. So I wanted to kind of figure out the model for like how much does the house consume in terms of electricity, and then in addition to that, how much does the car consume? And I can tell you guys that. So I've been sort of where I'm at right now is I'm trying to decide whether I should pull the trigger and put the solar panels right now, or just wait a few more years, because every year the solar panel energy density increases. And so that's the trade-off that I'm working through. But I'll just give you guys some numbers. Right now, if I were to spend after federal tax deductions and everything else, it would cost me about $28,000 to get solar panels installed without batteries. And that's because in our state, you can sell, or the power utility buys the electricity that you make in excess. So you don't need to have batteries for that purpose. So I would spend $28,000 in order to cover 90% of my electricity bill, which includes basically my transportation bill, right? Because I drive an electric car. And what I'm trying to figure out is, should I wait a little bit longer and then get a higher density solar panels in order to, completely offset that? Because if I were to get a second electric car, obviously my energy usage would go up somewhat, and it depends on how much I drive. So that's where things are relative to solar. And I don't know for people that are following, like the solar panels have basically quote unquote cratered in cost over the last year. And I think there's a surprise in the solar industry itself, in the solar panel industry itself, about how fast the industry has able to gain the manufacturing efficiencies and drive the cost down and increase the density. So that trend is continuing, and it will continue probably for the next 10 to 15 years. So that's on solar.
Yeah, it'd be nice if battery technology and would do the same thing. And I know one interesting thing, just kind of while we're talking about it, it's a little specific, but I'll mention it. There is a perception, or a lot of people think, that when I get solar panels installed on my house, that means if the power goes out, I will be able to use the energy that I'm harvesting in that moment from the solar panels in my house. The truth, that's actually incorrect. Seattle City Light, because they do net metering and because your solar panels backfeed the grid, there is an automatic shutoff that the utility company requires, so that when the workers are repairing the grid, they know that there is no energy in the grid coming from people's solar panels. So as you're planning for that, that's an important thing to kind of keep in mind, that if you're on these sort of preparations for power outages, if that's one of your criteria, then you know, a battery component in the system needs to be a part of what you're planning for. And everybody in the industry is waiting for batteries to get better. And
Yeah.
less ecologically destructive and yeah, kind of better in every way, right?
Yeah.
So.
And I should say, thanks to Tesla and the things that they did in the car industry, the net result of that is that the battery technologies has advanced significantly. So much so that when I requested quotes from the couple of solar installers in the area, completely unsolicited, or like I didn't request it, but they basically gave me a couple of quotes for, hey, here's a system that contains batteries as well. And interestingly, if you decide to just go to tesla.com and size up their solar panels for your house with like some super simple math, they will also give you two quotes, one with batteries and one without batteries. So the trend is definitely towards, like, you know, the battery systems are getting there to the point where you can have them, but they do take a little bit more space, right? That's the...
Yeah. There's a question from Dave about seismic considerations and elements in the passive house design. You know, passive house focuses almost entirely on energy use. So the oversight that we have for, is the building going to stand up in wind and earthquake, all comes from the city. And those aren't any different for passive houses. You know, and all of those things, the things that you do to make a house rigid dovetail nicely with the things that you do to make it energy efficiently. Like, there's not a lot of conflict between those two goals as you kind of detail it and sort of come through. So, you know, there are, in the industry as a whole, there are cases where, you know, there's a term called resilience, where you do make certain civic buildings, you know, libraries and hospitals, you double or triple the safety factor and the design criteria, the seismic design criteria for those structures, because in the event of a natural disaster or whatever it is that really puts a strain on seismic loads of buildings, you really want those not only standing but working as they were designed. But in houses, you don't really see that. So all of the structural considerations are pretty standard here. There's only a few spots where Taylor mentioned it before, thermal bridging, where engineers really like structure to connect. Energy modelers like for things to be disconnected and have some space between them, so that even the wood bones of a building doesn't conduct heat. But you know, those are fairly simple to accommodate. They're becoming even more simple. The good thing about this is as this movement grows, you know, approaches to solving all of these problems are traded freely within the industry. And, you know, we talk with other builders and other architects very often about very pragmatic solutions and new materials and things that we can use, so that we can all build better homes, and we can do things, build them better and make them more accessible to a wider range of people simultaneously. Yeah, those are all of the things that we're kind of undertaking. So
yeah. I should say, my wife, this is an interesting question, because my wife actually, for some reason, like, really worries about earthquakes. I mean, right, we are in an area where we should all worry about earthquakes.
Not for some reason, for a good reason.
Yeah. Yeah. I mean, yeah, we also grew up in a city in the south of Europe that was devastated by an earthquake when our parents were growing up. So, like, our parents have memories of, like, their city being decimated by earthquakes. But anyway, what I was going to say is, that's actually one of the reasons why I'm holding back on putting solar panels on the roof, is because my wife says, well, like, look at all that weight that will now be on the roof. What if there's an earthquake and we're, like, sleeping? Which is a very valid, you know, point. Right? So So it's one of the things where like if the energy density of the solar panels increases enough, that I could like cut down the need for solar panels by 30 or 40%. And then like the placement becomes easier. Those are the sort of inside baseball trade-offs that any human makes.
The good news is, and this is the case for, and it's kind of funny, one thing that's changed in Seattle code since is you're required to design the roof for future solar panels in any house in Seattle now. But we definitely considered that in the structural design, that there would be panels. So the house is already designed both from a load and from an seismic standpoint for those panels. So you load it up. Don't worry about it.
I'm not overly worried about it. As a matter of fact, when we were building the roof, right, like most of the insulation on the roof is foam. And I made it a point to bring my wife to the construction site to show her that, hey, look, like all of this insulation that's above your head, like, don't worry, because it's foam. Yeah. Like if there was an earthquake that was so strong that even your ceiling fell down, like it mostly would be foam.
For scale, the lighter end of a lot of solar systems, particularly the ones that fit on metal roofs where you're kind of the rack, all of the other attachments that outside of the solar panel itself are fairly minimal. We're looking at 2 to 3 pounds a square foot for those systems. And when you think about, the metal roof itself approaches 1 pound a square foot. So as you kind of weigh all of those things and sort of think about the scale of, all of the building materials that are up there and everything that's on the roof, we're not adding a lot, thankfully. I was surprised to hear that. I was expecting 5 or 6 pounds a square foot. But yeah, 2 pounds a square foot is pretty light. So that's a nice thing.
Well, it was really, it was a fun project to do. We definitely are cheerleaders of the Passive House project. If anybody has any more questions, here's our email addresses. Please feel free to reach out. We'll talk your ear off about any and everything having to do with this. We feel like it's the way to go, and we're a little bit behind in the States. I mean, there's whole cities. Belgium, I think, is entirely, their baseline code is Passive House. So everything is being built that way, and so I think this is the future, and it's getting easier to do. The premium on this and cost is coming down because now more subcontractors and more builders and stuff are understanding how to build this way. And it's kind of interesting, once you learn how to build this way, it's hard to go back because you know how much better it is, like especially from just the basic, just thermal comfort, indoor air quality, longevity, durability, lower carbon footprint. This is the way to go. A few more chats. Yeah, cost per square foot. That's we're not really telling people what the cost per square foot exactly is, because it's just from a privacy standpoint from the owners. But what we can tell you is, a lot of people ask us what the premium is. And of course, it's a hard question to answer specifically, and I'm not dodging it, but because it kind of depends on where you're starting from. So if you came to us and we're starting from a baseline, just a spec house or a baseline code house, if you bought from a speculative builder or something that a builder built in your neighborhood and just sold it, I mean, I think you could argue the premium would probably be in the kind of 10% to maybe 15%. A lot of our clients are already doing a lot of energy efficient homes to begin with, and so that's a lot lower markup because we were maybe already doing a little exterior insulation or maybe doing nicer windows. But I think we mentioned before, like the cost premium from going from a window that's kind of a baseline vinyl that meets code, it's a good window, but up to windows and doors on a project like this, that's going to be your biggest cost delta, as much as 2 or 3 times the price of the baseline. But if you're already doing, like I said, like nice wood clad window, aluminum wood clad or something like that, the premium isn't that much, so the markup wouldn't be that much to do something energy efficient. And we're big fans of kind of talk people into building a little bit smaller. Maybe if you can build a house a little bit smaller, a little less square footage, the cost goes down, and you can make up for that in the details. And if your goal is to be energy efficient or even passive house level, if we start that way from the beginning of the project with that in mind, we can design the house from both a simple, maybe make the shape simple. We can, again, we've been talking about, like the way you site the house. Just if you could just put it on site it on the lot or property in a way that maximizes your solar gains and heat losses, you're saving a lot of money on how much insulation. A good example, we're doing a passive house right now that's seeking certification in kind of the Fremont area. They didn't have the budget that this client had, but their number one goal was to be passive house from the get-go. So that's how we approached it. And a good example is we did 5 inches of exterior insulation on this project. Well, on that one, we're only doing 2. So the markup on that insulation is not that much comparatively to this project. But this project had some goals, some of the program elements that the owners wanted, really tall ceilings, or like the floating front, or some of these windows that were the floor to ceiling and tall, where we didn't do that on the other project. They're really cool, but they dinged us on the energy model. So in that case, in this other project, it was our primary focus, and the markup, that house is coming in at much lower cost per square foot than this one. They're still doing passive house certified windows, but they're not, the Unilux, for example. So there's a way to do it if you start out from the beginning where it's not too bad. Sorry, I missed how much wood is in your project. Are you going to be impacted by a huge increase? Well, this one's done, so we're not impacted in this case, but it's definitely impacting some projects we're working on now. Luckily, wood, as far as framing, is not a huge percentage of the overall cost of a project. I mean, most of your costs are in your finishes. So while there is some impact to some projects right now with the cost of wood going up, it's not something we haven't gone through before. It happens every year during hurricane season. A lot of times they go up because of the amount of wood that's being used down there, and yeah, so it'll come back around. It's interesting. The cost of wood isn't because of COVID. I was just reading that yesterday. It's just a general supply and demand issue, and that's it. You guys, again, maybe I'll stop to share for a second, and so I can see who's up. If anybody wants to ask any questions, you can. I mean, there's only, what is there, like kind of 14 of us. So anyone wants to kind of unmute or undo their video, don't be shy. We're happy to kind of answer questions in real time versus the chat for a few minutes before we kind of restart the presentation here.
Yeah, I was, it's Richard here. I was interested about what you said about the utility room being in the middle of the house, because my old house has that, and I'm hoping to solve the problem of the noise coming from the old furnace. So I'm just curious, what do you do for air intake for the components that are in there, and are they, I assume they're pretty quiet, being modern systems?
Yeah, so I'll answer quickly, and then I'll let Rade also answer, because he lives there and lives with it. The unit itself, there's not a lot of vibration that comes from it, so because it's not fuel fired, it's electric. Again, we're really mostly talking about a fan. So what you're going to hear from both the ventilation and the heating and cooling systems is mostly airflow flowing through ducts. So, the things that kind of bound that, the larger your ducts are, the less they whistle. That's a design component that HVAC designers consider. Round ducts whistle less than rectangular ones. So in the peak moments, where it's really hot in the summer, if it's 95, 98 degrees outside, the system's working pretty hard to keep the house cool. You know, there is in this home, there is duct noise, but there is no, you know, there's no vibration from a fan or, you know, a larger, you know, in the wintertime, it's not like a furnace is firing natural gas and, you know, pushing a lot of air through the house. In this house, the heating and cooling contributes more to the ambient noise that you hear in the house than the HRV. This is a ducted system. The ducts are very short. That's part of what this system needs, short duct runs, in order for it to maintain its efficiency. And so that was a major component we were really working on. So it does have supply and return, but the difference is it itself does not pull outside air into the house. Like Taylor mentioned before, it's sort of recycling interior air while the HRV is doing the exchange and supplying fresh air to the home. Did that answer your question?
Yeah, thanks. I mean, yeah, obviously I have a lot to learn, but it's encouraging to know that I could potentially do something like that in a remodel.
Absolutely. And you know, these systems, the mini split systems, work very well with sort of retrofits and rehabs. I live in a house that was built in 1955. There's nothing particularly fancy about it from an energy standpoint, but it does have the ductless mini splits. You know, they're quiet, they're decentralized. And so there's a lot of advantages to them, just aside from their efficiency. So, yep.
Yeah, I was just gonna add, this touches on something that we mentioned noise. My wife and I were extremely peculiar about not having noise transmission inside. So like each room being quiet, and this was really informed by the fact that we've lived in a few houses in the U.S. where like you can literally hear people talk in the living room where you're like sleeping in the bedroom that is above. And so one of the things that we did, and like, you know, if you're considering the remodel, like I don't think it was a whole lot of cost to basically put sound insulation between every room. And with that, like when the door to the mechanical room is closed, which is like 99% of the time that's the case, like literally you cannot hear the HRV system working. And then to Kevin's point, the main duct that basically sucks the air that goes through the heating and cooling system, like the main duct is actually at the like top of the wall, right there where the mechanical room is. And when the system is running at like medium or high speed, this is the air cooling and heating system. So this is the split system. You can hear the air basically whooshing through, right? Because the volume of the entire air from the house basically gets sort of like brought back there. But if you close the doors to any of the other rooms, like you can hear it in the hallway, you can't hear it anywhere else. Like you can comfortably sleep. Like we've slept a couple of the last nights with like the AC running on. The one thing that I will say is that we went, like last year was our first year in the house. Like we were still kind of learning and we didn't have shades, which was definitely causing a problem. Kevin talked about the west facing windows. They were definitely overheating that room and some of the hallways. But anyway, after the shades were in, like that was mostly addressed, and we really don't even run the AC or the heating inside the house. This summer, I think we've turned it on like twice or three times. So that's
right. Thanks. Congrats. Amazing house.
Thank you. It was a long way. Though I'll just, I mean, for the people that are on, I'll just tell you guys, like, I don't know anything about, I mean, I don't know anything about construction. Like, I could build a simple table out of 4 sticks. That's about as much as I know about construction. But my wife and I kind of decided, maybe even naively, to jump into this project. And my 2 biggest learning lessons and pieces of advice that I could give people who are considering this is the number 1, find people that you and work with people that you trust. That's like, you know, And because there will be all sorts of problems. So that's point number one. And then point number two is in the construction industry, I've learned this for myself. Maybe this is obvious to many people who are closer to the construction industry, but like you can't predict the speed at which a project gets executed. And that in many cases is completely independent of the competence of the people that you choose to work with. So like there were many times when I'm sure Kevin and Taylor will share with you that I was frustrated with the project because of like, you know, things that Kevin touched on, like people had to come in, right? Like the schedule of the project was just pushed out. But ultimately, if you work with people that you trust, and if you sort of mentally come to the conclusion that if you choose to do this, the trade-off will be that it will take a little bit of time. Like it's definitely the most fulfilling experience you could do in terms of like, you know, if you value the kind of house that you live in. Those are the 2 points that I would sort of impress upon you as you're considering embarking on a journey of either major remodel or building a house from scratch.
Thanks. I think that's great advice for everybody, Roddy. Cool. So
if you're not careful, we're going to make you our new client ambassador. We're going to have to like put you on the payroll as the expectations manager.
Yeah, exactly. Passive house and expectation cheerleader.
Yeah.
Cool.
I mean, Kevin and Taylor were like, you know, they run a company that's fairly small, and like in hindsight, this should have been obvious to me, but right, like they, you know, like when the plumber flakes out, like they're not building 150 houses, so they don't have the leverage to tell the plumber, hey, if you don't show up, you don't get the rest of the business from us. And right in Seattle, where like houses are going up like grass, right? Like the plumber's like, oh, you're not gonna give me your next project. I'm like, so I'm so sad. I'm just gonna walk across the street and get the other one. So right, like when you work in that environment, right, like the only thing that you have to like learn to be patient about is, well, it's gonna take time. So if the plumber doesn't show up this week, and you know, if Kevin decides to fire him, it's gonna take another week and a half to finish that part of the project. And that's where you have to learn to be patient. But those are things that I think the environment in Seattle is not gonna change anytime soon. And it's exceedingly unlikely that anybody would find a architect and design company that is building 190 houses in parallel, and you could show up and be like, I really care about sound, and I would really like these 7 other attributes of the house to be met. And you know, they're exceedingly unlikely to be like, hey man, like we just don't have time for you. Like we love that you have these, you're peculiar, but like we just don't have time. So that's the trade-off, right? Like in hindsight, it's an obvious trade-off.
Yeah. All right, Amanda and Peter, any last questions? Okay.
All right.
Thanks, guys. Thank you.
Thank you.
Thank
Enjoy
you,
the rest of your day.
Yep.